Okay, let's kick things off with a look at scalable AI architectures. Basically, as our AI systems grow and handle more data, and trust me, the we need to make sure they don't break. Traditional setups can get bogged down, so scalability is all about being able to add more computing power or resources as needed. We're talking about adding more machines, boosting the capacity of existing ones, and even automatically adjusting those resources based on how busy things are. It's like a smart system that scales with demand. Okay, so when we're designing AI systems, it's really important to think about how everything fits together. We want to build modular systems. That means creating independent pieces that can work on their own and easily connect with each other. The first key is loose coupling, which essentially means minimizing dependencies between those components. Changes in one area shouldn't break the others. Next up is high cohesion, where each component has a specific job, making them easier to manage and understand. Then we use abstraction layers to shield users from the inner workings of any module. Finally, aiming for reusable components. Think building blocks you can reuse across different parts of your AI system that really boosts efficiency and reliability. Let's talk about how we can tackle the challenges of scaling AI. Often, large AI projects end up as big, complicated systems that are hard to manage and update. That's where microservices come in. Think of them like individual, specialized pieces of an AI puzzle. Each one handles a specific task. This makes it really easy to scale things up when you need more power for certain parts of your system, or quickly swap out older models with newer ones without disrupting everything else. Plus, if one piece breaks down, the whole thing doesn't go down. We'll also look at some key practices like using containers and API gateways to keep things organized and secure. Okay, let's dive into how we can really get our AI models out there. We're going to focus on Docker and Kubernetes, a fantastic pairing for scaling your AI projects. Docker creates self-contained packages for your code and everything it needs to run, ensuring consistency across different environments. Then, Kubernetes is like a master conductor that manages these containers, automatically handling scaling, deployment, and even recovering from any issues. It's all about making things easier and more reliable and providing that crucial scalability we need as our models grow. Hey everyone, let's talk about scaling your AI projects. As models get bigger and datasets grow, traditional single machine setups just don't cut it anymore. That's where distributed computing comes in. Today we're focusing on two excellent frameworks, Ray and Dask. Ray is a super flexible system for managing distributed Python tasks. Think of it as a traffic controller for your AI code. It handles all the scheduling, makes sure things are running smoothly, and even takes care of any errors along the way. And Dask. It's really great at parallelizing data science workflows, especially when you're dealing with huge amounts of data. They both offer dynamic task scheduling, which means they can adapt to your needs as processing changes. Both have extensive documentation and tutorials if you want to dive deeper and start building your own distributed AI solutions. Okay, let's talk about how we scale AI systems. When your models get bigger and more people want to use them, you need to make sure they can handle the load. There are two main ways to do this. Vertical scaling, which is like upgrading a single computer with faster parts. It's simple at first, but there's a limit to how much you can improve it. The other approach is horizontal scaling, adding more computers to work together. This gives you almost limitless scalability and makes your system more reliable, because if one computer fails, the others keep going. It often ends up being more cost-effective in the long run too. Okay, let's talk about getting your AI inference services running smoothly. A key part of that is load balancing. Think of it like directing traffic to different lanes on a busy highway. We have several techniques we can use. Round robin is the simplest, just sending requests evenly between servers. But if some servers are stronger than others, least connections directs users to the server with fewer active tasks at the moment. You can also combine these approaches or even factor in location for faster response times. And remember, a good load balancer constantly checks if your servers are healthy and automatically removes any that aren't keeping things reliable. Okay, let's talk about serverless AI. It's a really exciting approach that's changing how we build and deploy AI applications. Basically, instead of managing servers yourself, you leverage cloud providers to handle all the infrastructure. This means amazing scalability. It can automatically adjust to handle tons of requests without you having to lift a finger. And because you only pay for what you actually use, it's incredibly cost effective. There are a few downsides to consider though. Cold starts. That initial delay when a function is called can sometimes be noticeable, and there's potential vendor lock-in depending on your cloud choice. Debugging can also be a bit trickier. But overall, serverless AI shines in use cases like image recognition API, creating dynamic chatbots, predicting equipment failures with sensor data, and even spotting fraud in real time. Okay, let's talk about making sure your AI systems are always up and running. It's not enough to just have a brilliant model. You need a pipeline that can handle the load and keep going even if things go wrong. We're focusing on high availability here, meaning minimal downtime. The key is redundancy, having multiple copies of everything, like your model serving and data processing parts. Load balancing is also important. It distributes requests efficiently. Plus, constant monitoring with alerts is absolutely essential to catch problems early. Automated failover is where the system seamlessly switches to backup when something goes down. And of course, protecting your data through replication and backups is fundamental for disaster recovery. Okay, let's talk about how to make your AI API gateways really robust. As more people start using your models, you need a way to manage all the requests without things slowing down or crashing. We've got some key design patterns that help with this. First up is the circuit breaker. It's like a safety net, stopping requests if one of your services starts failing, preventing problems from spreading. Next, we have rate limiting, which prevents anyone from overwhelming your system with too many requests. Then there's request routing and composition, which allows you to intelligently direct traffic to different models or even combine responses for better efficiency. Finally, API versioning is important for keeping things stable as you make changes over time. Remember, monitoring and observability are key. You need to be able to see what's happening so you can keep your gateway running smoothly. Okay, let's talk about spreading out your AI workloads. Instead of relying on a single cloud provider, we're looking at multi-cloud deployments. Think Amazon Web Services, Microsoft Azure, and Google Cloud Platform all working together. It sounds complicated, but it's incredibly powerful. You can tailor each cloud to its strengths. Maybe you use AWS for the heavy lifting of your models, Azure for analyzing massive datasets, and GCP for actually building those models in the first place. We're also looking at strategies like running things simultaneously across multiple clouds, so if one goes down, another instantly takes over. Data residency is a big deal too. We can deploy our AI closer to where the data lives to speed things up and make sure we're following all the rules about privacy. And of course, cost optimization is key, constantly monitoring usage and moving workloads around to get the best deals. Finally, security needs to be consistent everywhere, strong access controls and policies across all those different environments. Okay, let's talk about getting the most out of your AI cluster. We're focusing on GPUs, those powerful graphics processors that are really speeding up AI tasks. The key is not just having them, but knowing how to use them effectively. Think of it like a team. You need to put the right people, or in this case, GPU, in the right jobs. We're looking at dynamic allocation, which means automatically adjusting where workloads go based on what they need more GPU power for demanding tasks. Then there's hierarchical scheduling, so we can use different levels of GPUs together to balance performance and cost. Plus, resource pooling lets us scale the cluster up or down easily without having to buy and set up new hardware all the time. And finally, constant monitoring, tracking how each GPU is being used and tweaking things as needed. It's all about making sure we're maximizing every bit of processing power. Okay, let's talk about securing your AI applications through their API. Think of these API as the front door to your models and data. The first thing we need to focus on is authentication, making sure only authorized users can access them. Then, it's vitally important that you rigorously validate any input coming into the API, preventing potentially harmful attacks. Rate limiting protects against overwhelming traffic, and secure data transmission using HTTPS is non-negotiable. Finally, don't forget about protecting your models themselves from malicious inputs. Okay, let's talk about how we can really break down our AI systems by using microservices. Think of it like building with Lego bricks. You have individual pieces that do specific things, and they work together to create something much bigger. Each AI model, whether it's recognizing images or analyzing text, gets its own little container, a microservice. This means we can scale those models independently based on how busy they are, which is hugely beneficial. Plus, if one of these services hiccups, the rest of the system keeps running smoothly. It's also great for flexibility. You don't have to use the same tools or technologies for every part of your AI stack. Let's talk about scaling your AI workloads effectively. Many AI applications experience fluctuating demand, and simply having too few resources leads to poor performance or slow response times. Kubernetes offers a fantastic solution here, especially with its horizontal pod autoscale or HPA. The HPA constantly monitors things like CPU usage and memory consumption of your AI pods and automatically adds more pods if needed, or removes them when demand drops. It's all about reacting to real-time needs, boosting efficiency, and making your system much more resilient to unexpected spikes in activity. Okay, let's talk about keeping track of all those AI models you're building. As your AI systems grow larger, the number of versions can explode. That's where versioning and model registries become super important. Versioning is like a detailed logbook for each model. It allows you to go back to earlier versions if something goes wrong or if you need to recreate an experiment exactly as it was. A model registry, on the other hand, acts as your central hub, storing all of this information about your models, everything from how they were trained and what data they used, right through their performance metrics. Think of it like a database for your AI creations. Popular options include tools like MLflow and Weights and Biases, and even some cloud providers have built-in model registry services. Let's talk about making our AI pipelines more manageable. When you build a really complex system, it can quickly become hard to update and scale. The good news is there are tools that help us break things down into smaller, reusable pieces. Think of them like Lego bricks for your AI workflows. We're going to look at Airflow and Prefect, two popular options for orchestrating these modular pipelines. Airflow uses a graph-based approach, while Prefect takes a more code-centric view. Both help us build systems that are easier to maintain, faster to develop with, and much better equipped to handle increased workloads. Ultimately, this leads to more robust and secure AI applications. Let's talk about getting AI running safely out in the real world, specifically on edge devices. These things like your phone or smart thermostat are now capable of running AI models themselves. But because they're often outside a secure network, we need to take extra precautions. First, we have to make sure the model itself hasn't been messed with during its journey to the device. Think digital signatures and checks to verify it's genuine. Then privacy is huge, especially when dealing with personal data. We want to encrypt everything, ideally all the way through. And of course, strong authentication is essential. Only authorized devices should be able to access the model. Finally, securing the device's startup process and managing updates securely are vital steps in maintaining a safe edge environment. Let's talk about building AI systems that can really grow with your business hybrid cloud architectures. Think of it as the best of both worlds. You keep your most critical, sensitive data and applications in a private environment, maybe on-premise or a close co-location facility where you have maximum control. But for things like model training, large-scale analytics, and those bursts of activity, we leverage the massive scalability and flexibility of public cloud providers like AWS, Azure, or Google Cloud. It's all connected through secure channels, and that architecture gives you incredible benefits from easy scaling to cost savings, increased resilience in case of problems, and ultimately better data governance. Okay, let's talk about keeping the data flowing securely within our AI platforms. Think of it like this: data is the fuel that powers everything else. We absolutely need to protect it during transfer. There are a few key protocols we use, things like TLS and ISEC, which encrypt all the information in transit, making it unreadable to anyone who might be trying to snoop. And for extra security, we often employ mutual authentication, verifying that both ends of the connection are really who they say they are. Finally, techniques like data masking and tokenization help protect sensitive info by replacing it with safe stand-ins. It's all about making sure our AI systems aren't vulnerable to attacks. Okay, let's talk about scaling your AI data processing. It can get really tricky and slow down the whole process if you're not careful. The good news is there are some great ways to tackle this. First, we can use distributed processing frameworks like Spark or DAS to spread the work out across many machines. Another approach is to build a microservices architecture. Think of breaking your processing steps into smaller, independent services. Serverless functions like AWS Lambda are also fantastic because they automatically scale up and down as needed. And finally, don't forget about data partitioning. Splitting large datasets into smaller chunks can significantly boost performance. Okay, let's talk about keeping your AI models fresh and reliable. As you scale your AI systems, it's not enough to just build a great model. You need a way to consistently update it without causing chaos. That's where CI/CD pipelines come in. We're focusing specifically on how these pipelines work with modular AI architectures, which break down models into smaller, manageable pieces. Think of it like building with Lego bricks rather than one giant structure. Each brick needs its own testing, and the pipeline ensures those bricks are consistently built, tested, and updated as a whole. It's about automation, from defining your components to packaging them for deployment, and even having automated rollbacks if something goes wrong. Let's talk about securing AI, specifically when we're dealing with large, complex systems. Traditional security just doesn't cut it anymore. AI introduces a massive new attack surface. The core idea behind Zero Trust is simple. Don't automatically trust anyone or anything trying to access your AI resources. Instead, verify every single request and only give people the bare minimum they need to do their job. Think of it as never trust, always verify. We'll want to segment our systems into smaller pieces, micro-segmentation, so that if one part gets compromised, it doesn't bring down everything else. Strong identity management and continuous monitoring are also key to detecting threats in real time. Let's talk about building AI data lakes. They're awesome for storing all your raw data and feeding it into AI models, but you need a really solid plan in place to keep things secure. First, we'll start with scalable storage. Think of cloud services like AWS S3 or Azure Blob Storage that can handle massive amounts of data. Next, we design our processing pipelines using modular components like Apache Spark, so each part can scale up or down as needed. And crucially, we implement role-based access control, meaning users only get access to the data and tools they absolutely need. It's all about keeping things secure and minimizing risk. Let's talk about how we can design AI workflows that really scale. Instead of a huge, complicated process all in one place, we're going to break it down into smaller, independent pieces, microservices. Think of these microservices like specialized teams, each focused on doing one specific job within the larger AI system. The key is how they talk to each other through events. When something changes, an event is fired, and the relevant microservice automatically steps in to handle it. This creates a super flexible and scalable architecture because you can easily add or remove teams as needed without disrupting everything. Okay, let's talk about container orchestration, specifically with Kubernetes, and how it helps us build really robust ML pipelines. Think of it this way: we're packaging up all the different parts of our AI conversation system, like recognizing intents, pulling out key information, and crafting a response into self-contained containers. This makes scaling incredibly easy. If demand spikes, Kubernetes automatically adds more container instances to handle it. It also breaks down our pipeline into smaller, manageable pieces, making development and maintenance much simpler. Plus, containerization offers a significant security boost by isolating each component. Kubernetes gives us powerful tools like role-based access control and network policies to keep things safe. Okay, let's talk about scaling AI models, specifically how we train them when they get really big. The key is distributed training. Think of it like this: a single computer just can't handle the massive amount of data and calculations needed for state-of-the-art models anymore. So we split the job. We use techniques like data parallelism, where each machine gets its own copy of the model and works on a different chunk of the training data. Then we synchronize everything to ensure everyone's learning the same thing. Model parallelism is another approach. It's about splitting the model itself across multiple machines if the entire thing wouldn't fit on one device. There are also hybrid approaches that combine both techniques for maximum efficiency. Of course, there are challenges involved, like communication between machines and making sure things don't break down during training, but these are issues we're actively tackling. Okay, let's talk about making sure our AI systems don't just break down when things go wrong. Building fault tolerance is key. It means designing your AI to keep running even if parts of the system fail. We can do this by deploying multiple copies of our models in different locations. Then, we need really good monitoring so we get alerted immediately if something isn't working right. And crucially, we should have a plan to quickly roll back to our previous stable version if necessary. Adding circuit breakers can stop problems from spreading, and data replication and backups are essential for recovery. Okay, let's talk about keeping your AI system safe, specifically how we handle sensitive information like passwords and keys. As AI becomes more complex with lots of different parts working together, it's really important that we don't just throw all those secrets right into our code. That's a huge security risk. Think of it this way: if someone gets access to your code, they could get access to everything. We want a much better solution. We use things like vault or key management systems. These are central places where we store and control all our secrets. It also helps us rotate those keys regularly, so if one gets compromised, the impact is limited. Finally, it's critical to give each service only the minimum access it needs to do its job. That's what we mean by least privilege. Let's talk about securing those AI inference API. They're becoming really important in many applications. The key is to use an API gateway. Think of it as a gatekeeper for your AI services. First, we need strong authentication and authorization, making sure only the right people can access them. Rate limiting protects against floods of requests, and rigorous input validation prevents bad data from sneaking through. Finally, a WAF adds another layer of defense against common web attacks. I've shown you a snippet of how you might configure this using OpenAPI. It's all about putting these safeguards in place to keep your AI system safe and reliable. Okay, so let's talk about how to design AI systems that can handle lots of different users without breaking a sweat. We're focusing on multi-tenant architectures, basically like an apartment building where everyone shares the same hallways and elevators but has their own private unit. There are a few different ways we can structure this. One approach is a shared compute layer, which means all tenants use the same processing power. That's great for cost savings, but you need really good security in place. Then there's separated databases. Each tenant gets their own database, giving them maximum control and privacy, though it can get pricier. We also have shared services with tenant ID, which lets us share common things like model serving while keeping data separate. Finally, policy-based routing allows the central system to decide where requests go based on the specific needs of each tenant. Remember, security, monitoring, and scalability are absolutely critical no matter which pattern you choose. Okay, let's talk about securing our AI systems. A big challenge is that AI models need lot of data, and often that data is sensitive. Traditional security just doesn't cut it when you have complex pipelines with different stages. That's where end-to-end encryption comes in. Basically, we encrypt the data right from the very beginning when it's being brought into the system all the way through every single step: processing, training, storing the model itself, and even when we're using that model to make predictions. We're talking about protecting everything at every point in the pipeline. It's a critical layer of defense against potential problems. Okay, let's talk about scaling those video processing pipelines. They can get really demanding. The key here is thinking modularly. Break your pipeline into smaller, manageable chunks. This lets you spread the work out across multiple computers and makes updates much easier. Then we want to scale horizontally, meaning adding more instances of each module so everything runs in parallel. Cloud services like AWS Lambda are great for this kind of distributed architecture. Don't forget about caching. Storing frequently accessed video segments reduces the need to reprocess them constantly, which helps with performance and cost. And finally, security is paramount. Make sure each part of your pipeline is protected, using things like TLS encryption to keep your data safe during transmission. Okay, so we're tackling the challenge of getting these huge transformer models out into the real world. The good news is there are some really clever ways to do it. Essentially, because they're massive, we can't just run them on a single machine. We need to distribute the workload. We can break the model itself up, that's called model parallelism, or split the data across multiple machines. And there's even pipeline parallelism, where you process the data in stages. PyTorch provides tools like DDP to make this much easier, and services like AWS SageMaker offer a managed way to deploy your models at scale. Okay, let's talk about securing those crucial data assets, your AI data lakes and feature stores. These are the foundations of many modern AI systems, but they can be vulnerable if not properly protected. We need to think carefully about access control, making sure only authorized individuals have access to the right data. Data masking and anonymization techniques help us safeguard sensitive information while still allowing for model training and evaluation. And crucially, we need robust auditing and monitoring to track what's happening with our data and spot any unusual activity or potential breaches. Finally, don't forget encryption, both when the data is sitting idle and when it's moving around. Okay, so as we're building these modern AI systems, it's really important to think about how they'll grow and adapt. We want them to be scalable, meaning they can handle more data and users without breaking a sweat. And because AI is complex, we break it down into smaller, modular pieces, like microservices, which makes updates and reuse much easier. Finally, security needs to be baked in from the start. Think about who has access to what, encrypting your data, and constantly checking for vulnerabilities. Cloud services like AWS, Azure, and GCP offer tons of tools that make this process simpler. Things like SageMaker or Vertex AI help you train and deploy models at scale. Okay, so let's talk about how we tie our AI pipelines into a strong data governance strategy. Think of it like this. Building great AI models is only half the battle. You also need to know exactly where your data is coming from and how it's being used. Tracking data lineage, enforcing policies around access, and continuously monitoring data quality are all vital steps. There are a bunch of tools out there that can help with this, like Apache Atlas or Colorbox, which really give you visibility into the entire data lifecycle. Okay, so let's talk about service meshes and how they fit into our bigger picture of building robust AI systems. As your AI infrastructure grows with different models running alongside data pipelines and microservices, things can get seriously complicated to manage. Think of a service mesh as the glue that holds everything together, making sure all those pieces communicate effectively and securely. It handles crucial things like directing traffic intelligently, protecting against failures through circuit breakers, and ensuring no single component gets overwhelmed. Plus, it gives you really detailed insights into what's going on under the hood, metrics, tracing, logging, so you can spot problems fast. Basically, service meshes free up your AI teams to focus on building those amazing models instead of wrestling with infrastructure headaches. Okay, let's talk about getting your AI models out into the world, specifically how we actually serve them. There are a few frameworks that really stand out when it comes to this process. We've got TorchServe from PyTorch, Triton Inference Server, and FastAPI. TorchServe is particularly strong if you're already working with PyTorch because it's built for it, and it handles things like dynamic batching really well. Triton is a more versatile option. It can handle models built in different frameworks like TensorFlow or even ONNX, plus it supports various hardware setups to boost performance. And then there's FastAPI. It's super easy to use if you want to build simple API around your model and integrate it directly into your Python code. Each has its strengths and weaknesses, so choosing the right one depends on what you're building and how you need it to perform. Let's talk about how to scale recommendation systems as your user base grows. It's no longer enough just to have a good algorithm. You need to be able to handle the massive amounts of data and requests that come with popularity. Cloud platforms like AWS, Google Cloud, and Azure provide excellent managed services to help with this. A microservices architecture breaking down the system into smaller, independent parts is really important here. Think of it like building with Legos. You can easily add more pieces as needed. And don't forget about horizontal scaling. That means adding more instances of each service to handle increased traffic. Finally, strategies like auto-scaling and caching are key to keeping things performant. Okay, let's talk about scaling your AI models. As demand for real-time predictions grows, a single server can just get overwhelmed. That's where high availability inference clusters come in. We essentially create multiple copies of your model and spread them out across different locations, think zones, or even regions. Smart Load Balancer then directs users to the fastest available server. And because everything is constantly monitored, if one server goes down, another automatically picks up the slack. This means you get consistent performance, increased reliability, and a system that can handle massive growth without breaking a sweat. Okay, let's talk about spreading your AI out to multiple regions. Think of it as building a super resilient network. It's not just about having more servers, it's strategically placing them around the world to make your AI faster and more reliable for everyone. We need to think about where your users are, what regulations apply to their data, and even how much it costs to run things in different locations. Then comes keeping everything synchronized, making sure copies of your data match up across regions. Load balancing is key. We want the closest healthy server serving each user. Autonomous region switching allows for seamless failover if one area goes down. And naturally, security needs to be consistent everywhere. It's a bit more complex than just one location, but ultimately it makes your AI much better and safer. Okay, let's talk about rate limiting. It's super important when you're building AI systems that need to handle a lot of requests. Think about it, as your AI gets more popular, the API endpoints it uses can quickly get clogged up. Rate limiting is like putting a gentle guard on those API, protecting them from being overwhelmed by bad actors or just too many users at once. It helps prevent things like denial of service attacks and ensures that everyone gets a fair share of resources, keeping your system running smoothly. Okay, let's talk about how Istio can really help with managing your AI services. Think of it as the conductor of your AI orchestra, making sure everything works together smoothly. Because AI deployments are complex, Istio steps in to handle a bunch of important things like controlling how traffic flows between different parts of your system, ensuring that all the communication is super secure, and automatically collecting data so you can understand exactly how your models are performing. Okay, let's talk about vector search, a really important piece of the puzzle when we're building scalable and intelligent AI systems. Basically, instead of comparing entire documents or images to each other directly, which can be slow with huge datasets, we represent everything as numbers in a high-dimensional space vectors. We use models like sentence transformers to create these vectors. Then, we store them in specialized vector databases designed for super-fast similarity searches. When you ask a question, it gets converted into a vector too, and the database quickly finds the most similar vectors. This technique is particularly useful for things like retrieval augmented generation or RAG, where AI systems need to pull information from external sources to answer questions more effectively. Let's talk about keeping your AI services safe, specifically how we manage those API keys. It's a really common problem. Directly exposing long-lived secrets is a huge security risk. The good news is there are better ways. We use something called tokenization, which basically means replacing those long keys with short-lived tokens. Think of it like giving someone a temporary keycard instead of their permanent address. It's also really important to follow the principle of least privilege. Only give your services access to ** exactly * what they need. Finally, strong auditing and monitoring are crucial. We want to be able to track how these tokens are being used and spot anything unusual. Tools like HashiCorp Vault can help with storing and rotating those tokens securely, and service meshes offer a powerful way to enforce security policies. Let's talk about getting to the why behind our AI models. As we build these scalable, modular systems, it's really important that we understand how they're making decisions. Model explainability, or MLX, is a key tool here. It's all about bringing transparency into our pipelines. Think of your system as being built from separate modules, like data cleaning and prediction. MLX isn't just tacked on, it gets integrated at strategic points, often after each module finishes its job. The goal? To provide explanations for why a particular prediction was made, things like which features had the biggest influence. It's about building trust and making sure our AI is fair and reliable. Okay, so when we're talking about AI models that are spread out like across many devices or a huge amount of data, traditional validation methods just don't cut it. We need smarter ways to make sure these models are actually working correctly and reliably. One really important technique is federated learning validation. Basically, we can validate model updates right in the edge devices themselves before they're combined centrally. This helps protect user privacy and reduces the amount of data that needs moving around. Then there's synthetic data, creating artificial datasets to test models in situations where real-world data is scarce or hard to get. Parallel testing involves splitting up your dataset and running validation on different computers at the same time, speeding things up dramatically. And finally, shadow deployment and /B testing let us safely compare a new validated model with our existing one in a live setting. It's like having a backup version running alongside the main one. Okay, let's talk about scaling your AI models effectively. We're focusing on how to automatically adjust the resources allocated to your inference endpoints. KEDA, or Kubernetes Event-Driven Autoscaling, is a fantastic tool for this. Essentially, it monitors metrics like how busy your endpoint is, often measured by CPU usage, and uses that information to dynamically increase or decrease the number of replicas running your AI model. It's all about keeping things responsive as demand changes. Think of it as a smart way to ensure your models always have enough horsepower when they need it, without over-provisioning. Let's break down how it works. You first define what you want to scale by, for instance, setting a target CPU utilization percentage. Then, KEDA continuously monitors the resource usage of your deployed endpoint and automatically adjusts the number of instances running, so you're always getting the best performance. Okay, let's talk about keeping your AI systems compliant with data residency rules. Basically, it's all about knowing where your data lives and making sure that location complies with laws like GDPR or the CCPA. The first step is to really understand the places your data comes from, whether it's internal files or information you get from outside sources. Then we need to map out which countries or regions have legal authority over each piece of data. Finally, we need to verify exactly where that data is physically stored, like a specific cloud region or server location. To help with this, many AI teams are building modular systems, separating things like data storage and model training so you can deploy your models in different locations depending on the regulations they have to follow. Okay, let's talk about keeping our AI systems safe. It's not enough to just have one layer of defense, we need a multi-layered approach. First, we focus on securing the data itself, using strong encryption and making sure only authorized people can access it. Next, we protect the models themselves, things like their weights and architecture, perhaps through techniques like differential privacy. Finally, we need to secure the infrastructure where our AI lives. That means hardening servers, containers, and cloud services with segmentation, monitoring, and regular patching. Security is something that needs constant attention. Okay, let's talk about how we're tackling the growing demands of AI inference. We've found that simply throwing GPU at the problem isn't always effective. It can lead to wasted resources and slowdowns. That's where GPU pools come in. They're essentially a smart way to manage our GPU capacity, automatically allocating them to jobs when they're needed. We prioritize critical tasks, monitor performance, and make sure we're getting the most out of every single GPU. It's like having a shared resource that's managed with intelligence. Okay, let's talk about moving your AI workloads from your own data center to the cloud. The first step is all about understanding what you have, really digging into your current systems, models, and how everything's set up. Then, we need to figure out why you want to move to the cloud. Maybe it's for better scalability or improved security. Once we know our goals, we start planning a data migration strategy that's not just about getting the data there, but doing it securely and efficiently. We'll use secure channels like dedicated connections to minimize risks during transit. It's a phased approach: assessment first, then careful data movement, always keeping security top of mind. Let's talk about keeping an eye on your AI pipelines. It's not enough for your models to work. They need to be reliable, secure, and efficient. We want to track things like how quickly predictions are coming back, that's latency, and how many requests we can handle at once, that's throughput. We also have to watch for changes in the data itself, called data drift, and make sure our models aren't losing accuracy. Plus, security is a huge part of this. Regularly checking for vulnerabilities and monitoring for anything unusual are vital. Finally, good logging helps us understand exactly what's happening behind the scenes so we can quickly fix any problems that pop up. Okay, let's talk about how we manage the massive amounts of data that fuel our AI system, specifically how we break it up into smaller, more manageable pieces. We're focusing on sharding within an AI data lake. Basically, sharding means dividing your data across multiple storage nodes. There are several strategies: horizontal sharding, where you spread data out based on a key like user ID; vertical sharding, which separates data by function or access patterns; hash sharding, which is really good for even distribution; and range sharding, that's helpful for things like time series data. It's important to think about factors like keeping related data close together, aiming for roughly equal shard sizes, and ensuring you have replication built in so your data isn't lost if one part of the system goes down. Okay, let's talk about getting your AI systems to work seamlessly across different cloud providers. The reality is that many organizations are now spreading their AI workloads, like training models or running predictions, across several clouds, and it can get really complicated. To tackle this, we need a central orchestration tool. Think of it as a conductor for the entire AI process. This orchestrator tells each piece where to go, makes sure data flows securely between them, and keeps all the model versions consistent everywhere. It's about bringing order to this distributed environment so that you can truly scale your AI initiatives. Okay, let's talk about how we deploy our AI models consistently and reliably. It's all about pipelines. We're looking at immutable AI model deployment pipelines, which is a really powerful approach. The basic idea is that once a model version is deployed, we don't change it directly. Instead of modifying the existing model, we create a new deployment pipeline that replaces the old one with the updated version. This means we use robust version control to track every single change, and automated testing at every stage from unit test to integration test before anything goes live. We also often use techniques like canary deployments, where we gradually roll out the new model to a small group of users first, letting us catch any problems early on. And crucially, we have a clear rollback mechanism in place, so if something does go wrong, we can quickly revert back to the previous working version. It's all about building confidence and minimizing risk, making sure our AI systems are predictable and reliable. Okay, let's talk about building a really secure AI system. We can't just throw a model out there and hope for the best. A crucial step is thinking about security from the very beginning. It's what we call security first. We want to think of our architecture as being built on principles like zero trust, meaning we don't automatically trust anyone accessing our models. Breaking things down into smaller, manageable pieces through microservices helps too. So if one part gets compromised, the whole system isn't affected. And it's vital to really check everything, validating and sanitizing all the data coming in. Plus, rate limiting and strong authentication are essential for preventing attacks. Finally, we need continuous monitoring, constantly checking our models for anything unusual that might signal a problem. Okay, let's talk about securing your AI platform, specifically around who gets to do what. Identity and access management, or AIM, is absolutely vital. Think of it as the gatekeeper for everything within your AI environment. We want a central place where we manage all user identities, often integrating with systems you already use. Then, using something like role-based access control, we can assign specific permissions based on what someone needs to do, rather than just giving them blanket access. And in more complex situations, attribute-based access control lets us be even more precise, considering things like user roles and environmental factors. Finally, let's not forget multi-factor authentication, adding an extra layer of protection beyond the simple password. IAM isn't just a nice-to-have, it's the foundation upon which all other security measures are built, protecting your data, models, and overall system integrity. Okay, let's talk about building robust AI systems. Kubeflow is a fantastic tool that really streamlines the process of getting your machine learning pipelines up and running smoothly. Think of it like Lego bricks for AI. Assemble them in different ways to create exactly what you need. It's built with scalability in mind, so if one part of your pipeline needs more power, you can easily scale just that component without affecting everything else. Plus, the modular design means you can reuse those components across various projects and teams, saving time and effort. And importantly, it integrates seamlessly with existing security measures. Okay, let's talk about rolling back AI models when things go sideways in production. It's not just about going back to an old version. It's a super important part of keeping things running smoothly and protecting users. We need ways to quickly fix problems without downtime. There are several strategies we can trigger rollbacks based on performance dips or changes in the model's behavior. Shadow deployments let us test a previous version alongside the current one before fully switching over. Blue-green environments allow us to quickly flip traffic to a backup. Canary rollouts introduce older versions to a small group first, giving us an early warning sign. And most importantly, we should automate these processes as much as possible with rollback pipelines that ensure they work consistently. It's all about being prepared and having a clear plan. Okay, let's talk about getting our NLP models out there efficiently, specifically by using serverless computing. This architecture is all about flexibility and cost savings. Basically, we package up our model like BERT or RoBERTa and deploy it to a service like AWS Lambda or Azure Functions. When someone sends in text data, let's say for sentiment analysis, that triggers the function to run the model and give you an answer. The best part? The platform automatically handles scaling up or down based on how many requests are coming in, so you don't have to worry about managing servers yourself. And of course, security is key. We need to make sure our functions only have access to what they need, validate all inputs to prevent problems, and protect the API endpoint with strong security measures. Let's talk about how we can get the most out of AI by strategically placing it where it needs to be. We often face a trade-off needing super fast responses, but also wanting strong security. Hybrid edge cloud deployment tackles this head-on. It's all about combining the speed and responsiveness of edge devices, think sensors and local servers with the power and flexibility of the cloud for tasks like training complex models or handling massive amounts of data. The system intelligently decides which task goes where, ensuring we get the best balance between performance, scalability, and security. Okay, let's talk about how we handle security incidents when things go wrong with our AI services. The first step is all about getting alerted. That means constantly watching for anything unusual in the models themselves, like a sudden drop in performance or strange data coming in. We also need to use threat intelligence to spot potential attacks. Once an issue pops up, we have to act fast to contain it by quickly shutting down the affected part of the system and limiting any damage. Then comes investigation, which is where a team of experts dives deep to figure out exactly what's happened. Finally, we recover by restoring the service or deploying a new version, and most importantly, we document everything so we can learn from our mistakes and prevent it from happening again. Okay, let's talk about getting your AI models where they need to be and keeping them running smoothly. We're looking at multi-environment workflow management, which essentially means handling your AI across different stages, from the initial development phase through rigorous testing, all the way to live production. Think of it like a carefully orchestrated series of steps. To do this effectively, we need to create detailed profiles for each environment, defining exactly what resources and configurations each stage requires. Then, automated deployment pipelines help us repeatably deliver those models. And crucially, we use dynamic scaling policies. If something's running slow or needs more power, the system automatically adjusts. Finally, constant monitoring is vital to catch any issues before they impact your users. Okay, let's talk about building our AI applications in a really smart way by using stateless microservices. Think of it like this. Each service is completely independent and doesn't remember anything from the last request it handled. This makes scaling up super easy because you can just add more services without worrying about them getting tangled up with each other. We'll focus on 3 key ideas: making sure each service doesn't store any information about past requests, being able to update or scale those services independently, and using events. Think of it like sending messages between services instead of constantly asking for updates. Let's talk about keeping your feature stores safe and able to handle a ton of data. It's absolutely essential. We need to think about protecting the data itself, both when it's stored and when it's being moved around. That means strong encryption and making sure only the right people have access. Auditing how features are used is key too, so we can spot anything unusual. And don't forget that as your AI grows, you need a system that can scale. Think big cloud providers like Snowflake or Feast. It's about building a solid foundation for reliable and powerful AI. Okay, let's talk about managing GPU in a shared AI environment. Think of it like a busy office with lots of people needing access to powerful computers. When everyone wants to use the same resources at once, things can get chaotic. We need smart ways to make sure everyone gets what they need without wasting money or slowing things down. There are some key challenges. Workloads change constantly, users have different priorities, and we always need to think about security. We've got strategies like tiered quotas, where users get assigned different levels of access based on their needs, real-time monitoring to see how GPU are being used, and dynamic adjustment automatically changing those quotas as things shift. And importantly, role-based access control ensures only authorized users can access specific GPU. It's all about finding the right balance between providing enough power for everyone and keeping costs under control. Okay, let's talk about protecting privacy when we're building AI. It's super important. Data anonymization is a key step in our AI pipelines. It's all about removing things like names and other direct identifiers so that even if someone tries to piece things together, they can't easily figure out who the data belongs to. Why do we do this? Well, not only does it protect people's privacy, but it also helps us comply with regulations like GDPR and CCPA, which are designed to keep our personal information safe. And frankly, building AI that respects privacy builds trust, and that's really valuable for your reputation. There are several techniques we can use, like hashing, where we turn sensitive values into unique codes, or tokenization, which replaces the original data with a different symbol. We also have advanced methods like differential privacy, which adds a bit of noise to the data while still allowing us to analyze it statistically. Just remember, though anonymization isn't a magic bullet, you need to choose the right techniques and use them thoughtfully. Okay, let's talk about keeping your AI pipelines running smoothly even when things don't go as planned. Resiliency isn't just a nice to have, it's essential for reliable AI services. We've got some really useful strategies here, things like retrying failed requests with a bit of wiggle room to account for temporary glitches, and circuit breakers that stop problems from spreading across your system. Redundancy is key to having multiple copies of critical parts, so if one goes down, another immediately steps in. And don't forget about dead letter queues. They catch any messages that consistently fail, allowing you to figure out what's going on and get things back on track. Finally, we look at different failover patterns like active-passive, where a backup is always ready, or active-active, which uses multiple systems to handle requests simultaneously. It's all about building confidence in your AI system. Okay, let's talk about keeping an eye on our AI models once they're out in the wild. It's crucial because models don't stay static, things change. The data they're seeing shifts as users interact with them, and even the model itself can drift over time. We need to proactively monitor this to ensure performance doesn't slip. The main challenge is handling a lot of data from many different models quickly. So, we use centralized monitoring tools that can gather all that information in real time. Then we employ automated algorithms to detect when things are changing too much, a sudden shift in the data distribution, for example. Finally, we set up alerts and even automate actions like retraining or rolling back the model if necessary. It's about staying ahead of the curve and maintaining reliable AI. Okay, let's talk about keeping our AI services safe, specifically around how we manage secrets. It's really important that we don't just hardcode things like API keys directly into our code or configuration files. That opens us up to a lot of risks. Secrets rotation is the solution. Basically, it means regularly changing those secret keys like passwords and access tokens before they can be compromised. We generate new ones, update our services with them, and immediately revoke the old ones. Tools like Vault and other cloud-based secrets managers make this process much easier and more reliable. Okay, let's talk about scaling AI content moderation. Think of it like this: as our online communities get bigger, the amount of content we need to review skyrockets. Just throwing more resources at a single system isn't always the answer. Instead, we want a smart approach, and that starts with modularity. We break down the moderation process into smaller, specialized components, almost like building blocks. Each block can be scaled independently, and we use microservices architecture to ensure they can handle increased demand. Thus, strong data pipelines and caching help keep things running smoothly and efficiently. And of course, security is absolutely paramount throughout this entire process. Let's talk about keeping your AI microservices safe. As you break down complex applications into smaller, independent services, it's crucial to secure how they communicate with each other. Think of it like a chain. If one link breaks, the whole thing can fall apart. One key approach is mutual TLS, which ensures both services are verifying each other before talking. Service meshes, like Istio or Linkerd, automate many of these security checks. And don't forget API gateways that act as gatekeepers and enforce policies for all incoming requests. Finally, always encrypt your data, whether it's stored or being sent around, ensuring maximum protection. Okay, let's talk about how we manage the flow of requests to our AI models. Imagine a huge surge in demand for your AI service. Suddenly, everyone wants to use it at the same time. Without careful planning, your backend could easily get bogged down. That's where an API gateway comes in. It acts like the front door, intelligently directing traffic to different inference instances, making sure everything runs smoothly and scales as needed. It also handles security, verifying who's asking for service and limiting usage to prevent overload. Think of it as a smart traffic controller for your AI models. Okay, let's talk about how we can make the most of our GPU when running multiple AI tenants at once. It's a common problem. You end up with a lot of idle power. The key is to be smart about sharing. We've got a few strategies that work well. First, dynamic allocation means assigning GPU based on what each tenant actually needs at any given time. Then, using containers like Docker can create really strong boundaries between workloads, keeping things safe and isolated. Virtual machines offer even more isolation, but might impact performance slightly. And finally, GPU pass-through gives a single tenant dedicated access, which is great for their specific workload, but it reduces flexibility overall. Don't forget, security needs to be built into every step of the process with network segmentation and proper access controls. Okay, let's talk about building trust into our AI systems. One really important step is implementing secure audit trails. Think of these as a detailed record book. They track exactly what happens behind the scenes when an AI makes a decision. Why do we need this? Because AI models are getting more complex all the time, and it's crucial to know how they arrived at their conclusions. We want to understand where the data came from, every change made to the model itself, and who was involved in what actions. Tools like MLflow or Kubeflow can really help us keep these trails organized and secure, making sure we have full visibility into our AI workflows. Okay, let's talk about how we get those AI insights right now. Stream processing is really crucial here. Instead of waiting for a batch job to finish and then acting, we're constantly ingesting data. Think sensors sending in readings or websites tracking user clicks. We use tools like Kafka to handle that massive flow, and frameworks like Flink process the information instantly, allowing us to detect anomalies, prevent fraud, or even give people personalized recommendations as they are interacting with this system. Crucially, we can integrate our pre-trained AI models into this real-time process for immediate scoring and action. Okay, let's talk about keeping costs under control when you're scaling up your AI projects. One really important step is resource quota enforcement. Think of it like setting limits, for example, how much CPU time or GPU power a specific pipeline can use. We define these quotas upfront, continuously monitor what's happening within the workflow, and if something goes over its limit, we automatically take action, sending an alert or even stopping the process. It's about making sure everyone gets a fair share of resources and avoiding those unexpected, huge bills. Ultimately, it helps us build a more stable, efficient, and sustainable AI system. Okay, let's talk about building robust AI systems. As we scale our models and make them more modular, it becomes crucial to understand where our data is coming from and what's happening to it every step of the way. That's where data provenance tracking comes in. It's essentially a detailed record of your data's journey from its original source all the way through each transformation and processing stage. Think of it like building a complete audit trail for your AI pipeline. We want to break our systems down into manageable, reusable modules, which makes scaling much easier. And of course, securing that entire process is non-negotiable. There are tools out there designed specifically for tracking this, so let's explore how you can integrate them into your architecture. It's all about building trust and ensuring accountability. Let's talk about how we secure our AI systems and make sure everyone has the right access. As companies start using more and more AI, managing who can do what becomes a huge challenge. That's where Enterprise AI Identity Federation comes in. Think of it like building a central hub for user identities, a single place to verify who someone is. We use protocols like OAuth and SAML to establish trust between all our different applications and the central hub. And crucially, we make sure that when a user logs into one system, the same information about them is automatically available in others, avoiding a lot of duplication and making things much more efficient. Okay, let's talk about deploying new AI models safely. A really effective technique is using canary releases. Think of it like a test run before you launch something big. We start by rolling out the updated model to just a small percentage, maybe 1% or 5% of your users. Then, we closely monitor things like how quickly the AI responds and whether there are any errors. We'll compare it against our existing model using a /B testing too. And importantly, we get feedback directly from those users who are seeing the new version. If everything looks good, we slowly increase the amount of traffic directed to the updated model until it's fully deployed. Okay, let's talk about keeping our AI model registries safe. Think of these as central hubs for all your trained models. They need robust protection. The first thing is access control. We want to make sure only the right people can do the right things with the models. Role-based access control means different users have different permissions, and strong authentication, like multi-factor authentication, is a must. We also need to be able to trace where each model came from and how it's been changed. That's data provenance and lineage tracking. And of course, we need to encrypt our models while they are stored. Finally, regularly scanning for vulnerabilities in the registry system itself is crucial. Okay, let's talk about scaling our AI models for time series data. As your data gets bigger, a simple model won't cut it anymore. We need to think about how to distribute the workload. One approach is to break things down into smaller, independent services like microservices, each handling a specific part of the analysis. Another strategy is model sharding, where you split the model itself across multiple servers. Feature stores are also really important for keeping everything consistent and streamlining feature engineering. Finally, distributed training and inference allow us to spread out the work across a cluster of machines. It's important to think about factors like latency and data distribution as we build these architectures. Okay, let's talk about securing our AI workflows. As we build more sophisticated systems, it's vital to control exactly who can do what. Role-based access control, or RBAC, is a really effective way to tackle this. Think of it like assigning different levels of access based on someone's job role. Data analysts get access to data, model trainers get access to training models, and so on. The workflow orchestration engine then automatically checks if these permissions are granted before any action happens. It's all about adding a layer of security and ensuring only authorized individuals can work with our AI systems. Okay, let's talk about getting those huge deep learning models up and running efficiently. As these models grow in size and complexity, they need serious horsepower. The good news is the cloud provides a fantastic way to scale. We're primarily focused on horizontal scaling. Think of it like adding more workers to a team to tackle a bigger job. Then there's model parallelism, where we break the model itself apart across multiple devices, and data parallelism, which duplicates the entire model and trains it on different chunks of data simultaneously. And for those occasional spikes in demand, serverless inference can be a lifesaver. Okay, let's talk about designing AI pipelines effectively. Instead of trying to build one huge, complicated system, we're going to break things down into smaller, manageable pieces, what we call modular compute nodes. Think of each node like a specialized worker in an assembly line. One might be focused on getting the data in, another on preparing it, and so on. This approach makes our systems much easier to scale up or down depending on our needs, keeps things tidy and simpler to maintain, and lets us reuse components across different AI projects too, which saves a lot of time and effort. Okay, let's talk about keeping our AI systems safe as we grow them. When building scalable and modular AI, security isn't an afterthought, it needs to be built in from the start. We need tools that protect all stages of the process. Think about securing your data itself, making sure it's encrypted wherever it is and always protected during transfer. Then there's model security. We want to test for vulnerabilities like adversarial attacks and constantly monitor models for changes that could impact accuracy. Finally, we need robust infrastructure security with strong access controls and network segmentation. Okay, let's talk about how message queues help make our AI systems more robust and scalable. Think of it like a sophisticated postal service for data. Each stage in your AI pipeline is like a different post office. Instead of waiting for the next step to finish before starting the next, each stage publishes its work as a message onto a queue. Another stage then picks up that message and continues working on it. This decoupling means that if one part of the system gets bogged down or fails, the others can keep running smoothly. It's all about building systems that are flexible, resilient, and can handle growing demands. Truly scalable. Okay, let's talk about keeping those AI pipelines from breaking the bank. As you scale up your AI applications, costs can quickly add up. The good news is there are several smart strategies we can employ to make sure our investment pays off. First, think carefully about how you store and access your data. Using cheaper storage tiers for less frequently used information can save a lot of money. Then let's focus on the models themselves. Techniques like pruning and quantization help us shrink the size without sacrificing too much accuracy. Next up, choosing the right type of computing instance, CPU, GPU, or TPU is key. And finally, batching requests and scheduling jobs for off-peak IOs can really make a difference. Okay, let's talk about building a robust system for our AI services. As these systems grow, they get really complex, lots of different models, data processing steps, and smaller services all working together. That's where a service mesh comes in. It's like a smart traffic controller that helps manage everything efficiently. Console is the brains of the operation. It keeps track of all your AI services and how they communicate. Envoy then acts as the actual messenger, making sure requests get to the right place, and handling things like automatic retries if something goes wrong. It's a powerful combination for keeping things stable and secure. Let's talk about federated learning and how we can make it secure. Essentially, FL lets us train AI models without ever needing to move the raw data, which is fantastic for privacy. But because it's decentralized, there are some serious security threats we need to address. Think of things like malicious participants trying to mess with the training process or even figure out what original data was used. To combat these issues, techniques like differential privacy and secure aggregation protocols are really valuable. We also use anomaly detection to flag anything that looks suspicious. It's a complex but vital area as we build more trustworthy AI systems. Okay, let's talk about scaling those powerful search and recommendation engines we've been discussing. The core idea is that as more people start using them, they need to grow, and growing traditionally can be really tough. That's where modularity comes in. Think of it like building with Legos. You have separate pieces, user profiles, product catalogs that each do the job well, and you can add more of those individual blocks as needed. We also use AI at different levels, from how we index the data so searches are fast to actually personalizing recommendations based on what each user likes. Finally, scaling means adding more resources like servers or using clever techniques like caching to make sure everything runs smoothly, even under heavy demand. Okay, let's talk about building AI systems that can really grow with you. We're focusing on serverless, event-driven pipelines. Think of them as automated workflows for your AI tasks. The key is using serverless functions triggered by events, things like new data arriving or a user interacting with an app. This automatically scales up when needed, so you don't have to worry about managing servers yourself. We break down the process into 3 parts. First, there are event sources that kick things off, like uploading files to a cloud storage bucket. Then we use serverless functions which do the actual AI work, and finally an event bus connects everything together. Security is also critical. It's not enough just to build something powerful, you need to protect it. We'll make sure our functions only have the permissions they absolutely need, carefully check all incoming data for potential problems, and never store sensitive information directly in the code. Okay, let's talk about keeping your AI API running smoothly, even when something goes wrong. A single point of failure in the cloud can seriously disrupt your applications, so we're looking at a strategy called multi-cloud failover. Basically, it means deploying your inference model, those things that actually do the AI work, across 2 or more different cloud providers like AWS, Azure, and Google Cloud. If one provider has an outage, traffic automatically gets routed to another healthy provider. We use something like DNS to make this happen seamlessly, and a global load balancer ensures that requests are distributed effectively. And of course, security is paramount. We need to maintain consistent security settings across all the environments. Okay, let's talk about how we package our AI models for maximum flexibility and reusability. We want to build systems that can scale easily, so a standardized packaging approach is crucial. Think of it like shipping containers. Each model needs its own well-defined container. We need clear versioning, just like software releases, so everyone knows what they're getting. Then, we need to manage all the dependencies, those libraries our models rely on, carefully to avoid compatibility issues and ensure everything works consistently. Configuration is also key. We want to store model settings in a readable format like YAML or JSON, making it simple to adjust them without messing up the core model. Finally, good documentation detailing what the model does, what inputs it needs, and how to use it is essential for everyone involved. Okay, let's talk about getting the right data into our AI systems. This slide is all about building those crucial data ingestion microservices. Think of them as specialized little helpers that gather and prepare information from all sorts of places. We want to make sure they're modular, so each one focuses on a specific task, scalable so they can handle big changes in the amount of data coming in, and most importantly, secure because we're dealing with potentially sensitive information. We've outlined some key considerations like modularity, scalability, and security. And to give you an idea, here are a few examples of microservices. One might pull product catalog information from your e-commerce database, another could clean up social media feeds, and yet another could process server logs. Building these services independently makes our overall AI architecture much more adaptable and reliable. Okay, let's talk about how we can speed up our AI workflows by using distributed caching. Think of it like this: a lot of AI tasks involve repeating the same calculations over and over again, especially when dealing with huge datasets. To avoid wasting time and resources, we want to make sure we're not recalculating things that have already been done. So, what we do is break up the data or intermediate results across multiple caching nodes, basically like having several mini caches working together. Each node stores a part of the cached information it needs. Then, there's a central service or system that keeps track of where everything is stored so we can quickly grab what we need. And finally, we have to make sure our cache doesn't get stale. We need a way to invalidate outdated entries. It's all about minimizing redundant work and getting results faster. Okay, let's talk about getting our data ready for the AI models. The very first step is often called tokenization, and it sounds a bit technical, but it's really quite simple. Basically, we break down large chunks of information like text or other types of data into smaller, more manageable pieces, which we call tokens. Think of it like taking a giant Lego set and separating all the individual bricks. Why do we do this? Well, it helps our models understand patterns and relationships in the data far better than if we just threw everything at them whole. It also makes things less complicated for the model to process. There are different strategies out there. Some break down text into individual words, others split words into smaller parts called subwords, and still others treat each character as a token. The best approach really depends on what kind of data you're working with and the specific AI task at hand. It's an important step for ensuring accurate results and building scalable pipelines. Okay, let's talk about making sure those modular AI API respond quickly. When you build systems out of smaller pieces, which is great for scaling, it's really important to watch the latency. Think of it like this: if one part takes too long, the whole system slows down. We can tackle this with a few key strategies. First, caching is your friend. Store frequently used data so you don't have to recompute it every time. Then, offload heavy tasks to background queues, letting them run without blocking the main flow. Route optimization means designing your API calls as efficiently as possible and keeping those modules themselves as small and simple as you can. And if you're doing a lot of calculations, consider using specialized hardware like GPU. It's all about finding the right balance to keep things snappy. Okay, let's talk about getting those AI pipelines up and running at scale. The key here is to think strategically. We're not just throwing models together. These blueprints focus on breaking down complex pipelines into smaller, reusable modules, like data ingestion, feature engineering, and model training. This modularity makes things much easier to manage and update. Then, it's all about scaling your infrastructure. Using cloud services and containers means you can easily adjust resources as needed, handling peak loads without a hitch. And crucially, security needs to be baked in from the start with access controls, data encryption, and regular vulnerability scans. Finally, we need continuous monitoring to track performance and ensure everything's running smoothly and efficiently. Let's talk about a really powerful way to scale AI, the GPU-based distributed inference architecture. Basically, we're using high-performance GPU alongside FPGAs to speed up the process of running our AI models. Think of it like this: the GPU handle the main work, but strategically placed FPGAs jump in to tackle specific bottlenecks, making everything much faster and more efficient. The whole system is designed to be modular, so you can easily add or change components as your needs evolve, which makes scaling really straightforward. It's a great approach for applications that demand both high performance and flexibility. Okay, let's talk about keeping your AI systems safe and running smoothly through logging and monitoring. It's like having a really detailed surveillance system for your AI models, but instead of cameras, it's logs. We want to collect all the data from everywhere: how your models are being used, what's happening with your data pipelines, even what users are interacting with. This information gets gathered into one central place. We also need real-time dashboards so we can quickly see if anything is going wrong, like slow performance or unexpected errors. And importantly, we use AI itself or other clever methods to spot any unusual activity that might signal a problem or even a security threat. Finally, it's crucial to keep detailed audit trails of everything that happens, tracking who did what and when. Okay, let's talk about scaling those massive transformer models we love. It's not just about building a great model, it's about getting it running reliably at scale in production. First, we need to think about making the model itself smaller and faster. Things like quantization and pruning can do wonders there. Then, we have to build an infrastructure that can actually handle all of that traffic, often using distributed inference tools. And finally, smart caching strategies are crucial for minimizing wasted computation. This slide highlights some key considerations you'll want to keep in mind as you move towards production. Thank you for watching.